Alright, so we are going to work the problem where Jerome Simpson jumps into the end zone. We're going to find his launch velocity. Okay, so first let's play the video. Yeah, and if it doesn't work, you have to click on watch YouTube. Watch it on YouTube. Pretty cool. Alright, so let's work this problem. We've got the distance that he went. We also have the height that he goes. So if we were to draw this out, we'll draw it over here in the corner. Then I'll put in the XY chart. So if we draw this out, we're going to just model him like that. Goes up, comes down, lands in the same spot. So we have the height, and we have the distance. So we have dx, and we have dy. Alright, so if you make your chart here, horizontal, vertical, we do not know Vx, we do not know the initial vertical velocity yet, but we do know that dx is 10 meters, so that means he goes across 10 meters, and then we know dy is 2.2 meters. Of course, acceleration is still negative 10 meters per second squared, and time is also unknown. So, like I've told you in all of these problems we've ever worked, go ahead and find time first, because that's going to enable you to find the rest. So, we're trying to find the launch velocity. Okay, so we want to know what his launch velocity was. So we need to get Vx, and we need to get Vy. And then with those two, we can find the angle. So we can find theta. So first, we're going to solve for time. And we're going to solve for the time it takes for him to get down, or from the very top to the bottom. Okay, and up here, we know that his velocity is 0 meters per second. And down here, we know that his vertical velocity will be whatever it was when he left the ground. So he has some vertical velocity, some horizontal velocity, and that will be the same at the end on both sides. Okay. Alright, so for the time, let's go ahead and use the height. Anytime you have the height, use that for time. And so we know that dy is equal to 2.2 meters, so we can just use the same equation we've been using to solve for time. So time is the square root of 2d over a, or you can just plug the stuff in there that you know. So time is the square root of 2.2 over 10. Leave out the negative if you're going to be putting it in a square root. It's just telling you the direction anyway. Not super important, especially not in finding time, since time can't be a negative number. So you have time ends up being square root of 4.4, which is 0.66. So the time is 0.66 seconds. Now, that's just the time to get down. So I'm going to put that on the y side, 0.66 seconds. That's the time to get from the very top down. But remember, he's also got to go up. Okay, so we need to multiply that by 2, and we get 1.32 seconds. So the total time is actually 1.32 seconds. So total time So, of course, on the horizontal side, that will be the total time because the entire time the horizontal velocity doesn't change. So that's the total time. Now, we can use our new givens, because we got the time, we can use that to find Vx and Vy, and ultimately use that to find the launch velocity. So, next step, I'm going to kind of wall some of this off here. Let's do this. So the next step is to find Vx. So Vx is equal to dx over t. So Vx is 10 meters, because he goes 10 meters, divided by the full amount of time. Okay, 10 divided by 1.32 gives us 7.6. So Vx is equal to 7.6 meters per second. Alright, so that is excellent. We need that. Now Vy is the initial velocity plus at. So I'm going to say that this is the final velocity here, because I'm going to go from the top down again, makes it easiest, because I know at the top my vertical velocity is 0. So really you're just solving for the final vertical velocity at the ground is going to be the same. So the final vertical velocity here is going to be the same as when it left here. So it doesn't make any difference which one you solve for. So I'm just going to solve it like this to make the math easier. So because this goes to 0, so Vy is just negative 10 multiplied by the time on the y side. So this is just half the time, because we only care about the time to get down. And of course, this is 6.6 meters per second. So there's your Vy. You put both of these in, so 7.6 meters per second and 6.6 meters per second. Now we go over here and we're going to find the launch velocity. So if you remember, now it's just an exercise in trig. So this is VL. We now know that Vx is 7.6 and Vy is 6.6. So to find VL, and we'll find that angle later, it's a 90-degree triangle, so that's just this, this is the resultant, which we can call, we could say VL is equal to the square root of x squared plus y squared, Vx and Vy, respectively. So this will be VL equals the square root of 7.6 squared plus 6.6 squared. Solve that out. Our launch velocity ends up being 10.1. So VL is equal to 10.1 meters per second. Now we got to find the angle too, since we're always trying to find the angle with the horizontal. That's what we always give you. So theta is going to be the inverse tangent of y over x, like it always is. So 6.6 over 7.6. That gives you 41 degrees. So theta is 41 degrees. So there's our angle, and there's our launch velocity. And that is how you solve that problem. Quite a bit of steps there, but you see that it can be done. It can be done. Now you'll get more practice with that. All right, signing off.